Alright, in this video we're going to be talking about how to solve quadratics using the square roots method. Just a little bit of background. So we've been kind of dealing with quadratics since like the last unit when we were talking about factoring, but we didn't actually put that word specifically to it. But it was in the polynomial format, like think back to the trinomials ax squared plus bx plus c. It was in that format. Really, if it has something that's squared, it's going to be a quadratic. But here is another way to solve quadratics. With this, when we go to solve it, there is no x term, so there's no bx in this case. We just have ax squared and we have c. So let's walk through this. In order to do this, you have to do these two steps first. Isolate your x squared. So for this example, x squared minus 49 equals 0. We're going to add 49 to the other side. So we have x squared equals 49. Then we're going to take the square root of both sides. Right? Now, in basically everything we've done so far, anytime we've taken the square root of something, we've just been looking at the positive version. So we know this is x equals 7, right? But that's not necessarily true because 7 times 7 gives us 49. Yes, we know that part to be true. But we can also say that negative 7 times negative 7 is also 49. So when we do this, we have to say that there are two answers, positive and negative 7. And because there are multiple answers and we're looking for answers, we're going to break these as a set. So we're going to say x equals, wow, that's supposed to be curly brackets, ignore that, negative 7 and positive 7. Right? Let's try some other examples. For number 1, we need to isolate that x squared, so we're going to add 16 to the other side. And then take the square root of both. So we're going to have x equals, remember that these now are always going to be plus and minus, because there's a positive and a negative version of this that would work. We know the square root of 16 is 4. So our answers would be negative 4 and positive 4. And if we wanted to, we could put these back in to make sure they work, and I should have done that for the first one. So like negative 4 squared is 16. 16 minus 16 is 0. 4 squared is 16. 16 minus 16 equals 0. So that's why we can do both. Great. We're going to jump around a bit. Jump to number 3. Now we are subtracting 25 to get rid of, to isolate the x squared. So we have x squared equals negative 25. We're going to take the square root. In your mind, you're probably thinking, well, the square root of 25 is 5, so would it be negative 5? Let's double check. So I'm going to put the square root of negative 25. And it's going to say no real answer, non-real answer. This is something that's going to be covered in a later class. But for us right now, we're going to say that there is no solution. So you can say 0 with a line through it, and s, no solution, any of those. So if you get a negative, we cannot have a negative underneath the square root for this class. That will change moving forward in your next math class. Right? Try some more. Number 4, we have to get x squared by itself, so subtract 7 on both sides. So we have x squared equals 81. Take the square root of both sides, and we have x equals plus or minus 9. So that will be x equals negative 9 and positive 9. Hopefully this is making sense so far. If it seems pretty easy, it is kind of easy, so hopefully you feel that way too. Number 5, we need to subtract 7 on both sides. We get x squared equals negative 3. We ended up with a negative. We cannot take the square root of a negative in this class, so we can jump to x equals no solution. Number 6, you may be thinking the same thing. I have negatives, but isolate your x squared first because that may not be the case. So if we add 5 to both sides, we have x squared equals positive 1 now. And then we can take the square root of both sides. So x equals plus or minus 1, or x equals negative 1 and positive 1. Okay. Moving right along with number 7. Now we have 6x squared. We still have to isolate the x squared. So in order to do that, we're going to divide both sides by 6. So we get x squared equals 9. Now we're back to something that you know is a perfect square, or should. So we can take the square root of both sides. X equals plus or minus 3. So x equals negative 3 and positive 3. We're going to skip 8 and go on to 9. So for 9, we have this fraction in front of x squared. Instead of dividing both sides by 3/4, we're going to multiply by the reciprocal, 4 over 3. So those would cancel, just leaving x squared. On this side, I have 12 times 4 is 48 over 3. 48 over 3 is 16. So now we're back to having a perfect square, where we can take the square root of both sides, and we get x equals plus or minus 4, x equals negative 4 and positive 4. Okay, we're going to do one more on this page and then flip over to the back. Let's do number 10. For number 10, we have a lot going on, so we need to get rid of the 5 first by adding it to the other side. Then we have to get rid of the 1/2. So we're going to do exactly what we just did in 9 and take this and multiply it by the reciprocal, which is the same thing as just multiplying by 2. So we have x squared equals 100. 100 is one of our perfect squares, so we can take the square root of both sides, and then we get plus or minus 10, or x equals negative 10 and positive 10. I know I keep saying these are perfect squares, and you're probably thinking, what happens if we don't have a perfect square? We will get to some examples, don't you worry. All right, moving on. Number 13. We need to get rid of the 108, so we're going to add that to the other side. Then we are going to divide both sides by 3. That's going to give us 36. And take the square root of both sides. So x equals plus or minus 6. X equals negative 6 and 6. Right? Now let's do something like 17. So in 17, we're going to start this off just like we would any other problem. Add 1 to both sides. Okay, you're probably thinking, well, 25 is a perfect square, but I got to get rid of the 4, right? And isn't 4 a perfect square? What's going to happen there? So let's go with that first. So we need to divide both sides by 4 before we do anything. So we have x squared equals 25 over 4. Now you're probably thinking, okay, how do we do this? Same process, we're going to take the square root of both sides. When we do this here, we end up with x equals plus or minus. When you have the square root of a fraction, you can say this is the same thing as the square root of 25 over the square root of 4. Since I can't actually divide them. then we can say, well, the square root of 25 is 5, and the square root of 4 is 2. So that this would be x equals plus or minus 5 over 2. So that would be x equals negative 5 over 2 and positive 5 over 2. Let's do another one like that, just in case that didn't make a whole lot of sense. So for 18, we're going to start off by subtracting by 16 on both sides. We end up with 49x squared equals negative 8. Then we're going to divide both sides by 49. So we have x squared equals negative 8 over 49. Alarm bell should be going off because we have a negative. We cannot take the square root of a negative, so we can go ahead and skip to x equals no solution. Had we got something that was like maybe a positive, maybe it was 16 over 49, then we could have found the square root of 16, found the square root of 49, and found the perfect squares for both and made this into a fraction. Okay. Let's jump to 19. Now here, your x squared is already isolated, and the only thing left for us to do is to take the square root of 19. And in your mind, you're probably thinking, well, 19 is in a perfect square, right? And you are exactly correct. So what we're going to do is put that back in our calculator. So here, square root of 19. We're going to get decimals because it's not a perfect square. And we're just going to put, let's say, 3 or 4 decimals. So 4.359 or 4.3589, either of those. So we say x equals plus or minus 4.3, I already forgot what they were, 358, or rounded to 9. So that would be approximately negative 4.359 and positive 4.39359. There we go. So anytime you don't have the perfect square, you can still do it. You would just need to actually put it in your calculator and see what those decimals are. So if we had one like number 20, add 41 to both sides, so you get x squared equals 41. You should be thinking, is 41 a perfect square? The answer to that is no, but I'm still going to take the square root of both sides, put that in my calculator as the square root of 41, see what I get, 6.403. So this would be about 6.403 negative and positive 6.403. Okay. If you have any questions on that, please come see me and we can work through any of those together. But you have time to go and practice these on your own. Let me know if you need my